In this lesson, we're looking at the furthest distance that a particle gets. And so our particle is the same one we've been working with. The position of the particle moving along the x-axis is given by s of t equals 2t cubed minus 9t squared plus 12t minus 4. Time is in seconds and position is in meters. When is the particle furthest to the left? We have to know how to translate this. So furthest to the left is a minimum of position. So if we think about our lines, we're interested in, we know time starts at 0, increasing, decreasing. Because we're working with equations, we have to have a plus-minus line, and that is the velocity there. So we're going to start with our equation here, and we're going to use it to find the positive and negative for velocity. Take the derivative to get velocity. Factor and find our zeros. See, between 0 and 1, these are both negative, so overall it's positive. So looking at position, we do need some additional information. First to the left on the interval 0 to 5. So this is going to be increasing, decreasing, increasing. So first to left, we're looking for minimum, so that could be right here or right here. So s of 0 is 2 times 0 cubed minus 9 times 0 squared plus 12 times 0 minus 4. So 0 plus 0 plus 0 minus 4 is negative 4. S of 2 is going to be 2 times 2 cubed minus 9 times 2 squared plus 12 times 2 minus 4. By the time we go and work all that out, we actually end up with 0. So let's see, when is the particle? The particle is furthest to the left when t equals 0. Because its position is a minimum. Okay. A related but slightly different question is, what is the greatest distance between the particle and the origin? And the origin is just the point where the position of the particle is 0. So what we're looking for is this sort of situation. We're saying, okay, we've got the x-axis, we've got a little particle that's running around. It started somewhere, it kind of went one way for a bit, and then it went back the other way, and then it kind of went here, and then it went there, and then it went back this way, and so on and so forth. And so what we're looking at is we're looking for the biggest distance that it went to the left, the biggest distance that it went to the right, and say which is greater. So what this means is it means find the max and min of position and see which one has a bigger absolute value. So if we look back up here, really what that means is it means that we're going to check all the potential minima and all the potential maxima of position and see which one has the greatest absolute value. So we were just doing these ones up here. Absolute value of 2 times 0 cubed minus 9 times 0 squared plus 12 times 0 minus 4. So we're going to find the absolute value of negative 4, which is 4. S of 1 is a potential absolute maximum. So we do that, that's 1. Absolute value of 1 is 1. Absolute value of 2, we actually already did this up here, it's going to be 0. And then 5. This one right here is the largest. This asks for the greatest distance, so it's asking for this number itself. The greatest distance between the particle and the origin on the interval 0 to 5 is 81 meters at time t equals 5.